Right, so welcome back to another OMG, it's core chemistry, and this is about measuring rates of reaction. So there are a couple of ways we can measure rates of reaction. The first thing we're going to look at is calculating rate. So there's two different ways to calculate rate. We could analyse on a curve, so this is something that we've done in class. So if the reaction is faster, the curve will be steeper and it'll go further up on your graph. If the reaction was slower, you might even be able to draw one underneath. So steeper curve equals faster reaction. So sometimes they'll give you this reaction, the slow reaction, they said add another curve if the reaction is faster. Something to notice is because if you're using the same mass and volume of something, then the end point's always going to be the same. So even if you get to the end point quicker, you can see here it's already at the end point, but the end point will always be the same. It won't be up here out the way. That's not going to happen. Okay, normally how we calculate rate then is 1 divided by the time. So they might say, what is the rate at 30 seconds? So you do 1 over 30, put that in your calculator, and that would give you a rate. And that kind of rate would be measured in seconds to the -1. That's the main way that we measure rate. They will give you that equation in the exam. The other way we do it is then to create a tangent and use a tangent line, okay? So when we use a tangent line, they might say calculate the rate at 30. So first thing you do is find 30, draw a dot on, and then draw your tangent as close to the curve, a straight line as close to the curve as possible. And then I would say to pick 2 times either side. So if it was 30, I'd go 20 and 40. Draw lines up and across, and then again up and across. And then you have to do the difference in y over the difference in x. So that's your x-axis. That's your y-axis. So my difference in x, always put the biggest number first, so it would be 20, take away 40. Then find my corresponding value to 40. So imagine that was 50, and then that one there is 25. You put that into a calculator and that would give you a number. Okay, it's normally a quite small number. You might even see it in standard form like 10 to the -3 or whatever, but don't worry, okay, just use it. So that's the second way that we can calculate rate. Let's talk about then different rate experiments. There's a couple of ways that you have to know about calculating rate. The 3 main ways are gas collection, so collecting gas. You could either use a gas syringe or a measuring cylinder. A gas syringe is more accurate, higher resolution than a cylinder. Loss of mass. So as the solid forms into a gas or a liquid, then the mass will change, normally a decrease, okay? It's measured on a mass-pound balance. Mass loss needs to be measured continuously. Cotton wool is added to the beaker to allow gas to escape. And the other one is colour change, so looking for a cross to disappear, timing how long it takes. A light sensor is a more accurate way of measuring rate as it gives a clear end point. So there are the 3 main ways you have to know about measuring rate. So, same kind of thing now, little knowledge check at the end. Check your answers, and then if you're not sure, we'll go through them. So a steeper curve means a faster reaction. How do you calculate rate on a graph? You make a tangent and then do the difference in y over the difference in x. How do you measure rate? So you measure gas given off, mass loss, or colour change. What equipment and method would you need to measure loss of mass? You need a mass-pound balance. And then you'd measure the start mass and then pick a time. So measure the mass every 30 seconds. And then you'll be able to plot a graph then against time against mass. How could I make gas collection more accurate? Use a gas syringe, not a cylinder. Okay, higher resolution. How could I make colour change more accurate? Use a light intensity meter. Okay, because then it measures. So say you've got an experiment there, it's changing colour. Got a lamp by here, giving off light. Okay, then you'll have a recording system by here. That's my little computer. And then it'll measure the amount of light going through this reaction. So obviously as the colour changes to dark, less light will go through. It's more accurate than just someone looking above. So if you got them all right, great, move on to the next topic. If you didn't, go back and watch the videos again and then try again.